In this learning objective, we're going to look at exponent rules. There's a lot of exponent rules, but we're going to look at two specific ones. All right, so the first thing is if we multiply two exponential expressions together, we add the exponents. All right, so multiplying exponentials together, we add, and then the opposite of multiplying is dividing, which makes sense. If we do the opposite of multiplying, we do the opposite of adding, which is subtracting. All right, so we'll see what this means when we do examples. All right, but multiplying exponentials together means you add the exponents. All right, so if I want to combine these examples, x cubed times x to the fourth. It's important they're the same thing on the bottom. All right, whatever that variable would be or number would be, they have to be the same due to the exponent rule. All right, but x to the third times x to the fourth. Again, we add those two exponents together, and that's the same as x to the seventh. All right, and that makes sense from what we know about exponents, because it's 3 copies of x times 4 copies of x. And together, as a whole, that gives us 7 copies of x. All right, so we're just adding the exponents. When we multiply, we'll do the same one here. X to the fifth times x squared, we add those two. This one also turns out to be x to the seventh. All right, and this one on the bottom, it's not obvious they're both exponentials, but whenever you have anything, right, any number or any variable, any variable by itself is raised to the first power. All right, so just like when we were doing fractions, any fraction you can always just put over 1, or any number you can just put over 1 to make it a fraction. Any variable you can always just put a 1 as the exponent. It's kind of just an invisible number we don't have to write because it doesn't really change anything. But then this helps us see that now we can do this as we're dividing, so we subtract the exponents. It's always the top one minus the bottom one, and we get x to the fifth. All right, so go ahead and combine these ones into a single term. All right, and this is what I got. I got x to the ninth because you're adding the exponents. The most common mistake students will make is they'll say this is x to the 20th because they'll also multiply the exponents. But multiplying here turns into addition there. All right, and again, just think about all the copies of x we have. 4 copies, another 5 copies. All right, together gives me 9 copies, not the 20. All right, so just remember when you're multiplying these things together, you're just going to add those two numbers. All right, with multiplication and division, we can kind of group things how we want. So once we start mixing in numbers with our exponential expressions, we can kind of treat them separately. So we can do our variables separately from our numbers, all right, because it's all multiplication or all division. All right, so what do we mean by that? I'd say we want to do this problem. If I got rid of the 2 and the 3, and it was this, all right, we just learned how to do that in the previous examples. We would just add these numbers, like x to the fifth. All right, and what the last I was saying is basically we can do this separately, so we can kind of do that as its own problem, and then we can do the numbers separately. 2 times 3 is just 6, and our final answer is going to be 6x to the fifth. All right, so we just kind of treat the numbers separately from the variables. Right, we can multiply the variable parts together, multiply the coefficients, the number parts together, and get our final answer. So in this one, we have x to the fourth is our variable part. Here we have an x, and in a previous slide we learned that's the same as x to the first. And our numbers, we have -3, and this negative sign, again, it's just a negative sign is the same as a -1. So we multiply the numbers together. -3 times -1 is going to become +3. And then we add our exponents. 4 plus 1 is 5. And the same thing is going to happen for division. I can think about the number part. 8 divided by 2 is 4. And then the variable part, x to the fifth over x cubed. All right, 5 minus 3 is 2. All right, so 4x squared is going to be a simplified version of that expression. All right, here's one for you to try on your own. Again, similar to the last slide. All right, simplify this into a single term. And the final answer is 2x to the sixth. 2 coming from 12 divided by 6 is 2. And then 7 minus 1 is 6. So that gives us 2x to the sixth. All right, so go ahead and practice these exponent rules. They're going to be important in what we do later, specifically the multiplying exponents together. I have a practice this, and it'll help you what you have to do with later.